on our simplifying complex rational expressions. So for our textbook, this is 8.3, the second half. You won't find a lot of problems in the textbook that mimic this, so I want to make sure we go over this thoroughly in the notes and have some extra worksheets to do. So we are adding and subtracting rational expressions just like we did in 8.3 part 1. And remember, with all of this content comes a lot of background content, knowledge of fractions with operations and working them properly, factoring, and domain restrictions. And domain restrictions come from looking at the denominator, that the denominator cannot be 0, and sometimes we are using our zero product property to solve. All right, so rational expressions are complex fractions. A complex fraction contains one or more fractions in its numerator, its denominator, or both. So I like to look at this as fractions within a larger fraction, okay? You're going to see something that looks like this, and this looks exactly like what we've already done in section 8.2, which was rationalizing rationalizing expressions and multiplying, dividing. So when I look at this problem, I see the x plus 2. I want to picture this over 1. And so I have this x plus 2 over 1, and then I would multiply by the reciprocal of x over 3. So this problem we've already done and we've looked at. Same thing with the last problem. We have this numerator, and we would multiply by the reciprocal here. So we would multiply by the reciprocal. And same thing here, we'd multiply by the reciprocal. And then we'd be able to cross cancel. The problem in this middle one is that I have fractions. I have two fractions in the top over this fraction down here. So I cannot come in and multiply by the reciprocal. I actually have to do this first. So anytime we have problems, the numerator is in parentheses and the denominator is in parentheses. Those are given. And so I leave this alone, I multiply by the reciprocal. I can leave this alone and multiply by the reciprocal, but then I would have to FOIL or distribute because I have more than one term up here. So what I need to do is I need to do the addition or subtraction first to get a single fraction. That is the goal here, to get a single fraction. So we're going to come back to this idea in a little bit. Okay. So recall that the bar in a fraction represents division, so we know that, we've visited that. And then you can rewrite a complex fraction as division problem and then simplify it. You can also simplify complex fractions by using the least common denominator of the fractions in the numerator and in the denominator. So there's some different methods here, and it's up to you what you do. Step 1 would be to write the numerator of the complex rational expression as a single rational expression. So that's what I'm talking about up here. Rewrite this as a single fraction. Get a common denominator, and we'd multiply x and x, and we'd rewrite that as a common fraction, or a single fraction as x plus 1 over just x. And then we'd still have it over 4x plus 5. So that's really it. It's just one extra step. Clean that up, and then we would multiply by the reciprocal. All right, step 2, write the denominator of the complex rational expression as a single rational expression. So that's what we're doing there. And if you look, this was already written as a single fraction, so we are set. All right, and then it says the next step is to rewrite the complex rational expression using rational expressions determined in 1 and 2. Okay, so here it is, that's step 3. And then step 4, simplify the rational expression using techniques for dividing. So what are our techniques for dividing? We are going to multiply by the reciprocal. Okay, and that's what we've been doing. All right, so let's get into this now that we've introduced it. What I see here is a complex fraction, and what's making it harder is this numerator. Okay, so I am set, the denominator set, I'm going to multiply by the reciprocal here. The problem is this, so I need to turn this into a single fraction. And so just to say it again and remind you, whenever I add or subtract, I need a common, denominator. All right. So, looking at that, what are the pieces? Well, this is what we had been working on. I need this to have a 4 and this to have a 4. And I need this to have an x and that to have an x. So my numerator is 8x plus x squared, and my denominator is 4x. So again, I built the common denominator, and whatever I did to the bottom, I did to the top. So previous lesson being used, as well as just prior knowledge of fractions. So now that I have my numerator, that was step 1 written as a single fraction. Step 2 in our steps to write the denominator as a single fraction, and it already is, so I don't have to do that work. And now we're back to the prior lesson, which we used as 8-2, multiplying and dividing fractions. So my numerator, I'm going to go ahead and factor out an x, and I'm left with 8 plus x all over 4x times the reciprocal of x over x plus 1. Now, some of you might look and say, well, you really didn't need to factor. The reason I factored was I was wanting to see if anything canceled. And there is something that cancels. So again, always factor GCF anything you can. And then you can pick. I see that this x can cancel with that x. Or you could have canceled this x and that one there. So it's a 1-to-1 ratio. X plus 1 stays because you can't cancel out of all three. So I am left with x times 8 plus x all over 4 times x plus 1. So you might get that answer in some places, but I prefer to distribute it. I'm actually going to put it in standard form. So x squared plus 8x, right? 8x, x squared, all over 4x plus 4. Okay, so if I take a minute and look at this, yes, it was already factored. I can take an x out of here, but I can't cancel it with anything. And I can take a 4 out of here, but I can't cancel it. So this is my final answer. And let's talk about, it says assume that all expressions are defined, but I'd still like to talk about a domain restriction. So when you're given assume all expressions are defined, you're basically being told don't worry about a domain restriction. But I think it's important to know it. So our domain restrictions come from our denominators. And originally we had an x in the denominator and a 4 up here. So x cannot be 0. Okay, so domain restriction would come from here, x can't be 0. It would come from here, x can't be 0. But remember, we're also dividing by this. So divided by 4x, divided by x plus 1, divided by x. And so x cannot be a -1. So I wanted to talk about that domain restriction. All right, so let's keep moving. That's it, guys. If you look at this as a simple problem of pieces, then it's not so bad. If you try to do all at once, it can be a little bit scary. So we've got a lot of check it outs. And honestly, 5a and 5b, they're nothing new. 5a and 5b are single fraction divided by single fraction each time. So when I go to do this one, I keep the x plus 1 in the top. I'm going to factor to x plus 1, x minus 1, and then I'm going to multiply by, so I'm going to multiply by the reciprocal, which is x minus 1 all over x. So there is nothing new about this problem. I was just multiplying by the reciprocal because I had single fractions. And I can cancel this x minus 1 with that x minus 1. I can cancel, because it's cross-canceling, I can cancel top to bottom. And I'm left with an x. But it's not just x, it is 1 over x. Okay? So the x was left in the denominator. Again, it says assume that all expressions are defined, meaning we don't have to worry about domain restrictions. But I think domain restrictions are so important that we want to practice those because they are going to be very meaningful in later lessons, solving as well as the graphs. So when I'm looking at this, I'm looking at my original denominator and my original denominator from the bottom and that piece in the numerator that I was dividing by. So x cannot be -1, +1. We already have the +1, and x can't be 0. So those are my domain restrictions. Okay, so off to this one, same idea, keep my 20, don't have to factor here, times, okay, this does factor, 3x minus 1 all over 6. All right, so by doing just that GCF, it shows me that that cancels out, but I don't want you to forget that 3 cancels with 6, just like it always would, and there's some left over. It's a 1-to-1 cancel. 3 went into here once, 3 went into here twice, but I can cancel this 2 goes into here once, and it goes into here 10 times. So my final answer, with all of that started, is just 10. 10 was left in the numerator. Let's talk about our domain restriction. What can't x equal? We're looking at any piece that was being divided by. So x cannot be 1. The 6 will never be 0. So there's your 1. 6 is fine, but the 3 came out. X can't be 1. So that's it. My answer is 10. My domain restriction is 1. Okay, this is what we were talking about here. And so I want to talk about this problem a little bit more. The bottom's fine. I'm going to multiply by the reciprocal. That's not the issue. The issue here is I have fractions, plural. So I need to get it down to single fraction. So I need to get a common denominator. So if you can just ignore this bottom, let's just cover this up and act like it's not there, just for now. Let's just cover that up. And if I had just given you this, that would actually be a very simple addition and subtraction problem, okay? So if I can just focus on this, I need to give this a 2 and give this a 2. And so my numerator is now 2 plus 1. Well, that's easy, right? Over 2x. 2 plus 1. So I really have 3 over 2x. So I have written the numerator as a single fraction, and I would just keep the denominator right here. Okay, so that's it. I'm going to take my 3 over 2x and leave that alone. And I am now going to multiply by the reciprocal, and nothing factors here, so x minus 2, I almost wrote that wrong. So x minus 2 over x plus 4. I went to cancel, and nothing cancels with anything. So my answer is going to end up being just distributing 3x minus 2 over 2x times x plus 4. And so if I distribute that, I get 3x minus 6 over 2x squared plus 8x. And that is my final answer. Nothing canceled. And I want to go back and talk about domain restrictions. They came from the denominator, so x cannot be 0. You can see that here. X cannot be negative 4 or positive 2. So again, x can't be 0. This came from the denominator, and this came from that numerator in the bottom. So x cannot be 0, 2, or negative 4. I guess if we're being proper, we'd put the domain restriction in numerical order, least to greatest. All right, well, here are some extra examples because I didn't feel like that was enough. So we've added some extra practice. This is a great time for you to pause it and see what you can do. So same deal, the denominator is fine. The numerator is what needs adjusted. So I'm going to put an x here. I'm going to put a 3 here. So I really have x plus 3 in the top. One of the mistakes is people want to make this 3x. It's x plus 3. And down here I have a 3x, all divided by x plus 3 all over 2. And that's it. So now I keep the numerator over 3x times 2 over x plus 3. And so what I see is that everyone looks at these and they just leave them blank. You know, when I would give a test or a quiz, they would just look at this and say it's too hard. In reality, I think these problems are easier than what we did when we simplified rational expressions with multiplication, division, and when we did just adding and subtracting. Because there's a lot less to it. You have an extra step to build a problem, but look at this. This is very simple. There's no big factoring here. There's no building huge common denominators. So actually, I really think this is an easier lesson. It's just a little more abstract to start. So, and it builds, so you have to have the other skills. So we can cancel out those x plus 3's, and I'm left with 2 over 3x. That's it. Very simple, not a huge mess, not a lot of work. Domain restriction, what can't x be? Okay, x can't be 0. the 2 will always be 2, and x can't be negative 3. So we're really just setting our denominator pieces, anything that we're dividing by, equal to 0 and solving. Okay, looking at this one, same deal. The denominator's fine, but this numerator needs some work. So I'm going to put a z here and here. I'm going to multiply this by 4, and I end up with z squared minus 16 all over 4z. So again, it's z squared minus 16, and the common denominator is 4z. So we need some prior knowledge of adding, subtracting fractions, but this was a lot easier than some of the big messes. And then down here I have z plus 4 all over 16. So I've written it as a single fraction. That's it. That's the first step. And now we're really back to basic division problem. Now this numerator factors. It's going to be z plus 4, z minus 4, all over 4z, times the reciprocal, which is 16 over z plus 4. And so these z plus 4s are going to cancel. And don't forget, 4 times z, 4z and 16, that 4 cancels out. So I am left with in the top a 4 and a z minus 4, and I'm left with in the bottom just a z. And that's all I can do. I cannot cancel more. Distribute this, and I get 4z minus 16 all over z. Now, once I have that, let's talk about that domain restriction. What can't z equal? Well, z can't be 0 from here, which holds true here. 16 is always going to be 16, and z can't be negative 4. So 0 and negative 4. All right, this next extra example is a little more challenging. Okay, there's more going on here, so we're stepping it up here. So what I really need you to look at is in the numerator, I have fractions plural, and so although the order of operations we multiply and divide before we add and subtract, we have to remember that this is truly like it's in parentheses there, okay? And this is as if it's in parentheses here. So we have to clean up the numerator, get it into one fraction. That was step 1. We have to clean up the denominator, get it into one fraction. That was step 2. And then we can jump back in and do our division rules. So I'm going to cover this up, and really what we're doing is we're doing 2 different addition and subtraction problems. So I'm going to focus on this numerator here. That's all I'm going to do. The first thing we want to do is talk about all those little rules. That minus sign, I might forget it. So I'm going to change this to addition of the opposite. You don't have to do that, but boy does it help. I want to look at this denominator, and I want to see that this denominator factors as x minus 16, or x minus 4 and x plus 4. I want to give myself some room here to work. So my numerator over here is 2x, and my denominator was x plus 4. We already changed our signs to negative x plus 7, and I want to factor that denominator as x plus 4, x minus 4. Okay, so this is that top piece, and I'm bringing it down. Now, when I go to do this, they both have the x plus 4, so this needs the x minus 4. So really doing an addition subtraction problem like we've already worked on. So in my numerator, I have a common denominator, this is going to take a little bit of work, of x minus 4, x plus 4. Now, in my numerator, I'm going to put a big plus sign. Again, I'm doing what I have already taught. I'm going to distribute that, and so I have a 2x squared minus 8x plus negative x plus 7. And so when I do this, I now need to clean it up. In order to add or subtract fractions, I need a common denominator, but I can't add the like terms until I clean them up. So my final numerator, I'm going to write it right here, I'm going to squeeze it in, is going to be a 2x squared minus 9x plus 7. And I'm going to go ahead and keep this factored. Remember, whenever we did this, we kept that denominator factored, and then we'll come back and we will try to factor that numerator. Right now, my goal was just to clean it up and get the numerator as a single fraction. I cleaned up the top, and I'm going to let this sit here. Okay, I'm going to come back to this and then keep working with it. Now we're going to focus on the denominator. So I'm going to go ahead and cover this up. All right, and I just want to focus down here. So I'm going to put a big fraction line, okay, to remind you that I'm now in the denominator. And so when I go to do this, I have my x over 1, okay? I have that negative sign because I'm subtracting, so I want to distribute it. So I really have x over 1 plus a negative x squared minus 4 all over x plus 4. So again, I need a common denominator. I need to get this as a single fraction. So anytime you have just a term here, like x or 5, you have to put it over 1 because you have to build a common denominator. So this would be x plus 4. And don't forget, even though that's an x there, you can't put a plus 4. You have to put in the x plus 4. All right, so here is my equal sign, and here is my thicker fraction bar here. And so the idea is my denominator is x plus 4. And then this piece would give me, I got my plus sign here, my big plus sign, x squared plus 4x. And then over here, I have that negative x squared minus 4. Okay, so let's clean this up. And my denominator, the x squared and the negative x squared cancel. And I have a 4x minus 4 left over, and the bottom is x plus 4. Okay, so now I've got my work to do. I want to look at this because, here we go. I am now focused on this. Okay, I'm sort of boxing that in because that is my focus. And so what I want to do is basically ignore everything else. Okay, so I took this addition and I worked it out up top here. We built it to get a we broke that down, we built that to get a common denominator, we put it all together, got a single fraction on top. We did the bottom, we built this up to get a common denominator, put it together, got a single fraction. So if I can ignore everything right here, what I need you guys to look at is see that I have a fraction divided by a fraction. So I'm going to factor anything that's not factored and multiply by the reciprocal. That's my goal there. All right, so the numerator has a little bit of effort to factor because there's a 2 out front. So we have to do a little trial and error, and it should factor as a 2x minus 7 and an x minus 1. All right, so let's double check that. 2x times x, okay, there we go. We've got a negative 2x, a negative 7x, and there's our negative 9x. Negative 7 times negative 1, positive 7. So I'm content. The bottom was already pre-factored because we needed it to get a common denominator. So that's good. And then I'm going to multiply by my reciprocal. So x plus 4. And then just a GCF, don't forget that. That's pretty important. And then I have x minus 1 left. So that's a lot of stuff going on. And the only thing that cancels right here and the x plus 4. Okay, so I do have a little bit of canceling. The numerator left is just 2x minus 7. In the denominator, I have the x minus 4 and the 4, which redistributes to a 4x minus 16. All right, so once I have that done, I've now solved my problem. Let's talk about those domain restrictions. What can't x equal? Okay, if you come back to the original denominators, x can't be negative 4, or positive 4. Okay, so we've got our plus or minus 4, that's for sure. Then we look, this x was always going to be an x, so we don't have a domain restriction from here. We do have a domain restriction that x cannot be negative 4. And I don't have to worry about this. I really should look right here when it's finally factored because nothing was canceled here. So positive or negative 4. If you factor out the 4 here, this was that x can't be 1 and x can't be 4. So we're set. There's our domain restriction. All right, example 4 is something that really stumps people, but it's actually easier than most of the things we've done. And so the numerator is fine. I'm just going to make it look like 1 over 1. I always like to build a fraction when I'm working in fractions. I need you to focus on this denominator. I have an x here, a y here, and a z here. So if this has an x, it needs a y, it needs a z. So this needs a y, z. And here's a trick. Whatever you do to the bottom, you need to do to the top. This has the y, so I need to build the x and the z on it, the x and the z on it. And this has a z, so I need to build the xy and the xy. So I don't think that's hard. A lot of people get that. I'm going to leave this as 1 over 1, and this is where people get stumped. My common denominator is x, y, z. Remember, that's the easy part. Once we get our common denominator, we just sort of funnel it down to one piece. The numerator is right here. It's one of these plus one of these plus one of these. So since this had an x, I had to put the yz on it. So it's yz plus, this had the y, so I needed the xz, plus this had the z, so I needed the xy. That's it. And so when I go to solve this, I still have division, so I'm going to leave my 1 over 1, and I'm going to multiply by the reciprocal, which is xyz over yz plus xz plus xy. And if I'm multiplying by 1, that doesn't change anything. If this was a 2 up here, I'd have 2 of these. So my final answer is xyz over yz plus xz plus xy. Domain restrictions would not typically be expected because there is more than one variable, but x can't be 0, y can't be 0, and z can't be 0. There's no addition or subtraction with numbers here, so x, y, and z can't be 0. There would be some other stipulations, more domain restrictions. If x is 2, then y and z cannot be -1. So we really could be here for a while. So this is the big idea. X, y, and z can't be 0, but there are other combinations. Again, if x is 3, that'd be 1/3. We have to watch that the combination of 1 over y and 1 over z doesn't become -1/3. Okay? So again, we do have to watch. And actually, x could be 2. We just have to watch that y and z don't add up. So I did say that wrong. So we do have to watch the combination here. Okay, so 2 more of these problems to practice. You can see that these are going to take a little bit of time here. Okay, so good place to pause and try it again. And so when I come and I look at this, I can see that I need to build a common denominator. So I'm just going to work within this problem. That has an x, so this needs an x. And an x. Please don't try to just put a -2. Everything has to be multiplied here. This needs an x minus 2, and so does the top. So in my numerator, I have x minus 2 plus x. And so I could rewrite all this, but I have a common denominator of x, and I have x minus 2. And I'm always going to leave that prefactored. My numerator, again, I had to give this the x minus 2, so I brought that up here because I distributed a 1. 1 times x is x, so I really end up having 2x minus 2. All right, I'm still dividing. Down here, this factors to x minus 2, x plus 2. All right, I'm adding, so I'm good there. And this needs the x plus 2, top and bottom. So when I go to do this, I have a common denominator of x minus 2, x plus 2. I like to make that a little thicker to make sure we focus on that. So in my numerator, and I distribute this, I have x plus x, which is 2x, but it's plus 2. All right, so here we go. When I go to do this, I'm going to factor out the 2, and I have x minus 1 all over x times x minus 2. All right, so I took out the common factor. I left that already prefactored, and then I'm going to multiply by the reciprocal. And so this was prefactored, and it goes on top. And this has a GCF of 2, so I take that out. So double check your factoring, and then I can look for things to cancel. The x minus 2 cancels. And I really wanted the x minus 1s to cancel, or this to cancel. It doesn't, but I do have this 2 canceling with that 2. So at this point, I am left with the x minus 1 and the x plus 2. And I am left with the x and the x plus 1. So I'm going to have to put this together. X minus 1 times x plus 2 over x times x plus 1. Again, you might see the answer written as that. I'm going to be asking for it to be multiplied out, so I'm going to FOIL the top. So I get x squared, and then I get a 2x and a negative x, so just a positive 1x minus 2, all over x squared plus x. All right, so take a second, you look at that. Let's talk about these domain restrictions. What can't x equal? Go back to your original problem. We're looking for here, x can't be 0 or 2. Okay, so that came from here, 0 or 2. And then if we look over here, we have this factored. This came down, so x can't be negative 1. X can't be 2 or negative 2. So I'm going to put a plus or minus on my 2 there. All right, there you go. Another one. We've got a lot going on here, and I want to make sure that we see one thing. This right here is where my problem is broken up, and this is all over 1. So when I'm working with fractions, I want everything to be a fraction. So I don't have to do much to this denominator. It's a single fraction, but I am going to change that sign. And a lot of people don't, but it makes a difference because you don't want to forget to distribute it later. Okay, so I need to give this the x plus 4 top and bottom. So there's going to be a little bit of prep work. And I need to give this the x minus 3. So same thing we were dealing with before. Keep that common denominator of x plus 4, x minus 3. And what I need to do is clean up that numerator. Okay, so I'm going to do a little bit of work above here. So I'm going to FOIL this, and I'm going to get x squared. Let me move this down there. I'm going to get x squared. I'm going to get a 5x and a 4x. So I'm going to get a positive 9x and a positive 20. All right, big plus sign here. The reason I wanted to distribute that negative sign is it has to distribute to these two. And if I forgot it, I might only get the negative x squared and not the sign change on the 3. So I do get a negative x squared, but I get a positive 3x. So when I go to clean that up, the x squared and the negative x squared cancel. 9x and 3x, that adds up to my 12x plus 20. So there is my numerator. And I still have this denominator here of 3x squared minus 4x minus 15 all over 1. Okay, so now I've got it down to a fraction divided by a fraction. And again, this is already pre-factored, so I'm just going to leave it. So when I go to do this, I'm going to take out the common factor of a 4, and that leaves me x plus 5. And then that's over x plus 4, x plus minus 3, times 1 goes on the top, and then I have to do a little work to factor this. It's not bad because it's a 3 out front. It factors to be, let's try a 3x. I want it to be plus 5 and an x minus 3. So 3x to the second, there's a negative 9 and a positive 5. Okay, there's my negative 4x and a negative 15. Perfect. So what cancels here? As much as I wanted this to cancel, I missed this right here. This should have a 3. Sorry about that. Double check. I had a 12x plus 20, and I thought nothing is canceling, and I realized that when I took out the 4, I missed my 3. Okay, so I had an error right there. Okay, so the only thing that cancels is that. One of the mistakes people make is they see the x minus 3s and want to cancel. I can only cancel if it's top to bottom by cross-canceling or just reducing a fraction. So I'm stuck with that. So in the top, all I have is 4. But in the bottom, I have x plus 4, x minus 3, and another x minus 3. So it's a little bit messy. So again, some places, that is it. Your answer is done. we're actually going to FOIL this out, and once I FOIL this out, I have to take the time and then redistribute. Or you could FOIL these two, okay, and maybe that's easier. You get x plus 4, and then since this is a perfect square, x squared minus 6x plus 9, and then I'm going to have to take the time to distribute the x to all the terms and the 4 to all the terms. So your final answer, once you distribute the x and the 4 and add all like terms, would be x to the third minus 2x squared minus 15x plus 36. So that would take a little bit of writing to do. Let's talk about our domain restrictions. What can't x be? Okay, coming from the original denominators, x cannot be 3 or negative 4. So negative 3 or 4. All right, the 1 is always going to be 1, that's fine, but I can't divide by 0. So we'd have to look at this. X cannot be negative 5/3. We'd subtract 5, divide by 3. X cannot be 3. So plus or minus 3 or a negative 5/3. And there is my answer. A little bit of a long one. Okay, so that is what you need for this lesson. I have here a word problem, so an application problem that I'm going to take the time and talk about. But I also have on the back some more practice and challenge problems, and you can see that we need to build a common denominator here. I don't think that one's so much of a challenge. I think the difference is there's 3 pieces, but this just goes back to part 1 where we're adding, subtracting fractions. Notice it's not a complex fraction. Same deal. What makes this one a challenge is that you have a negative power, and so we have to think about those rules. And then I don't think this one's a challenge. It's just an extra problem because it's something that we can do pretty basic. So I wanted to show you what's coming up, but I did want to still take the time and go over this application problem with you. All right, so here is our application problem. A freight train averages 30 miles per hour while traveling to its destination with full cars. Okay, so it's going a little slower with full cars, and 40 miles per hour on the return trip with empty cars. What is the train's average distance for the entire trip? And it says round to the nearest tenth. Okay, so we want the average speed for the entire trip. So here's what I need to remember. It is going to its destination and then returning. So D is equal to the distance going one way. The distance going one way. So we have this problem pre-broken up first, but I want to make sure that you understand this would typically not be here. And that's all you would get, okay? So what I don't know is the train's distance. And the reason I don't have the D as the total distance is when I drive there, when the train drives there, it's going 30 miles per hour, and I have to separate that with the 40 miles per hour because not the average speed. And a lot of people want to say, well, the average speed is going to be 35 miles per hour. And you're close, but it is not 35 miles per hour. That's not what it averages to. So the total distance on the trip is 2D, okay? The total time spent would be, and you have to remember this, T, time, is equal to D over R. So the time is equal to the distance over the rate. So when it says total time, we have to think about this. The time going there would be the distance, how many miles we go, divided by the rate of 30 miles per hour, okay? And then the time coming home with empty cars is the same distance, but we're dividing by 40 miles per hour. So this is my total time, okay? Distance, total distance divided by total speed. All right, so what is my average speed? Well, take this back. Individually, distance divided by speed, distance divided by speed. But if we're talking about the average speed, the total distance is 2D. And we are then going to divide that by the total time. All right? Because if you think about this, if we rearrange this and I multiply it out by R, I'd have T times R equals D. And if I want to divide for rate, I would divide by T. So time is equal to distance over rate, but rate is equal to distance over time. So I know that my total distance is 2d. D going, D coming home. I know my total time is found by averaging the time by adding the time for the trip there and adding the time for the trip home. Very abstract, but you have to think about it individually. So how do I find my speed? I take my total distance divided by my total time, because rate, which is speed, is equal to d over t. So I am building this. So I wanted to take the time to make sure we understood where each of these concepts came from. And again, total time came from this formula. Average speed comes from the distance over t. The distance we're using as 2d, and the time is based on adding up the times of each individual trip. So now this is why it applies to what we've done. If we look at this, I have a fraction divided by fractions. So I'm going to go ahead and put this over 1. So that's 2d over 1. And then we need to look at this and clean it up. Now, I have a denominator with a 30 and a 40. So to get a common denominator, I'm going to build it to 120. I'm going to multiply by 4. I'm going to multiply by 3. And so what I need to see is that I have a common denominator of 120. This numerator is 4d. This numerator is 3d. So 4d plus 3d is 7d. Okay, so keep my numerator over 1. I like to build that, times the reciprocal of 120 over 7d, as in dog there. And so the d's are actually going to cancel. The 2 has nothing to cancel, and the bottom with the 120 has nothing. So my answer here is 240 over 7. Now, if we go back to the directions, it said it round to the nearest tenth right here, round to the nearest tenth. So if I take 240 divided by 7, I get about 34.3. All right, so that's close to 35, but it's not 35. Now, what I need you to remember is, what is the label? And it's not supposed to be a guess. Where did this stuff come from? Well, we were finding the average speed, and the average speed came from the distance. So my numerator was how many miles we went. Remember, we were based in miles per hour, and my time, the total time, was based in hours. So we have 34.3 miles per hour, or mph. And there we go. That is my answer. Okay, so we have another problem. It's very similar to this. So it is going to be the same setup. Okay, so go ahead. This would be a great place to pause the video and read the problem and give it a try. And so we look at Justin on his way to school. His average speed is 40 miles per hour. So I'm going to guess he's driving. And his average speed on the way home is 45 miles per hour. Maybe there's less traffic. So what is Justin's average speed for the entire trip? We want his average speed to the entire trip around the nearest tenth. Okay, so we need to remember that time is equal to distance over rate, and that rate is equal to distance over time. So we'll let D equal, again, distance one way. Distance going one direction. Now, if you think about his trip, and we want to talk about this, his total distance is 2d. Okay? If we want to talk about his time is he's going the distance, and the distance divided by the rate is d divided by 40. But we're going to add to that his time coming home, which is d, his distance, divided by 45. So a lot of people are going to say, well, his average his average speed is about 42.5, and you're very close, but it's not exact. Okay, and so we want to be careful with that. It's going to be close to that, but it's not going to be exact, because we're talking about a rate of change, and that is not going to be divided evenly. So here's what I have. Again, I'd put this over 1, and so I have 2d over 1, and I need to clean this up. My common denominator is going to have to be 360. Okay, my common denominator is going to be 360, so we need to build to that. Alright, so it would take a little bit of time to figure that out. When I go to do this, I'm going to multiply this side by 9, and I'm going to multiply this side by 8. How do I get to the 360? Well, if you think about degrees, 45, 90, 360 degrees in a circle, and then on this part, 36 divided by 4 is 9, so 360, okay? So it takes a little bit of effort. So in the top, I get a 9D plus an 8D. So I get 17D, and my common denominator is 360. And so there you have it. I would keep this 2D over 1, and I'd multiply by 360 over 17D. The only thing that's going to cancel out here is the D. The 2 and the 360 are in the top, so I'm stuck with that. And so that gives me a 720 on the top and a 17 on the bottom. Now remember, my numerator was my distance. Okay, so this is how many miles. My denominator was my time. Add up the time going, add up the time coming back, and so this is in hours. And so if we divide, we get 42.4 miles per hour. And that is what it rounds the nearest tenth as. All right, there you go. So let's try these problems on the back. Again, I don't feel like these are a challenge, and these actually revert back to old concepts. So I think this might be a challenge because there's 3 pieces here, but we have practiced these. So I'm going to change that to a negative so I don't lose my sign. And then I don't want to build this up until I find the pieces. So if I factor this, I get an x minus 2 and an x plus 2. Now you do have a couple options here. You could have added like terms because they have a common denominator and clean that up and then built it, or we can just do it as one big problem. So I'm going to look at it as one big problem. Maybe it's a shortcut to go the other way, but it's not often that we can add these outside ones and then build. So I'm just going to go ahead and do it how we had been doing it. Alright, so I now have a common denominator of x plus 2, x minus 2. So this is a good review of just adding, subtracting. I'm going to put a big plus sign here and a big plus sign here. Over here I would FOIL this and I would get x squared. I get a negative 1x and a 2x, so a plus x and then a minus 2. Almost lost my x there. And then in the middle I didn't have to change anything because I already had the denominator. And then over here I'm distribute, so I get a negative 6x squared and I get a negative 12x. Alright, well now that I have that, I'm going to add like terms. So x squared and negative 6x squared is a negative 5x squared. I've got a negative 11x and a plus 4. So that is my numerator. And I think I need to double check something. Oh, sorry, negative 2 and 4. I do have an error there. So if we add that up, sorry, negative 2 and positive 4, I should have a 2 here. That looks better to me. Okay, next idea is my denominator. Before I rewrite this denominator, I'm going to take a look. This numerator, it doesn't factor. I'm not going to be able to find factors of this to add up to negative 11. Factors of negative 10 to add to negative 11. I can do trial and error. This is not going to factor for me. So I'm going to go ahead and leave the numerator. Maybe that was the challenge, and distribute the denominator by FOILing. And I get x squared, a negative 2x, positive 2x, and then my negative 4. Domain restrictions. What can't x equal? We're just looking at that denominator. X cannot be positive or negative 2. Okay, so what makes this next problem a bit of a challenge is negative exponents, but we know the rules, and the rule for a negative exponent is if I have a to the negative m, that is 1 over a to the positive m. So negative exponent is really telling you to take its reciprocal. Okay, so no problem. What I really have here in disguise is a fraction of 1 over x plus 2. Now notice my power is negative 1. So this would really be to the power of 1. So that doesn't change anything. Minus, and this would be 1 over x squared minus 4. And again, that was a power of negative 1. So it now has a power of 1 on it. And a power of 1 doesn't change anything. Now the next thing I want to do is change that sign. That way I don't forget it. And then now I think it's a pretty basic problem. Factor and find the pieces. Okay. And I need this to have an x minus 2. So I will build that. Top and bottom. And there you go. I have a common denominator of x minus 2, x plus 2. And I have a numerator over here of x minus 2 and a negative 1. So I have x minus 3. And I look at this, and this does not cancel with anything. Everything's pre-factored. So my final answer is x minus 3 over x squared minus 4. And what can't x equal? Remember, this power of negative 1 puts it in the denominator. So x cannot be negative 2 or positive 2. And again, we repeat that there. All right, last problem for us is right here. Again, I'm not sure why this isn't a challenge other than a review, but we've been using this concept. So we already have a single fraction divided by a single fraction. So I have x plus 2, and I'm going to go ahead and factor that. X plus 2, x minus 2. And then I'm going to multiply by my reciprocal, which is x minus 2 over x. And so what cancels out is the x minus 2. What's left is x plus 2 over x times x plus 2. Oh, I'm a goofball. That actually would have canceled out too. So I don't have any of that left. What I really have left is 1 over x. Maybe that was a challenge, was not missing that. Or maybe the true challenge was the fact that the x was left in the denominator, and so we make sure it's 1 over x. But that's something we've been talking about. What are my domain restrictions? X cannot be a positive or negative 2. X cannot be 0, coming from our original piece in the numerator, and x cannot be 2. And there you have it. All right, I hope that you continue practicing.